You have heard of the butterfly effect. Most people know the phrase, not the picture. A single point is moving by 3 rules. It traces 2 great wings in empty space. This is the shape it draws. Here is that famous butterfly, drawn in full. It was never about a real insect. It began with a computer guessing the weather. One tiny number changed the whole forecast. How can a rounding slip rewrite the future? Here is the plan for this discovery. First, a coffee break and a rounding error. Second, 3 rules taken from the weather. Third, the butterfly effect itself. Fourth, the shape hiding in the chaos. Finally, why tomorrow stays so uncertain. Now let's go back to 1961. A scientist was running weather on an early computer. He wanted to repeat one earlier run. So he typed in numbers from a printout. Then he walked away for a coffee. The computer stored 6 digits for each number. But the printout showed only 3 of them. So he typed in 0.506. The hidden digits, 1, 2, 7, were gone. That tiny gap was about to explode. Now let's see the rules behind the weather. Lorenz shrank the messy sky into 3 equations. They describe warm air rising and cooling. 3 numbers track the rolling, turning air. Simple rules, yet they never settle down. Feed those 3 rules a starting point. Step it forward, again and again. The point traces a long, looping path. It never crosses itself, and never repeats. A whole shape slowly fills the empty space. Here is the butterfly effect itself. Start 2 points almost exactly together. For a while, the 2 paths agree. Then they split and fly far apart. A tiny change rewrites everything. This is why the weather fights prediction. We can never measure today perfectly. A tiny error in the start grows fast. Within days, the forecast loses its grip. The math itself sets a hard limit. Now look at the shape this draws. The path loops around 2 open wings. It crosses between them, but never lands twice. The motion is wild, yet always bounded. Order and chaos share one shape. This looping form is called an attractor. Every nearby path is pulled toward it. The rules are fixed, with no randomness at all. Yet the future still cannot be foreseen. Determined, but unpredictable, at the very same time. So where did the butterfly name come from? At first Lorenz spoke of a seagull. By 1972, it became a butterfly. Could one flap in Brazil stir a distant storm? The image stuck, and the name spread worldwide. Look at the butterfly from new angles. Each view shows the same 2 wings. The lines never touch, yet stay close forever. It is chaos wearing a calm, ordered face. Beauty and limits, drawn by the same rules. This curve changed how we see the world. Tiny causes can have enormous, distant effects. Perfect prediction was quietly ruled out. A weather error became a law of nature. We still feel its wings in every forecast. So what does this butterfly leave us? The future is fixed by exact starting numbers. But we can never know them exactly. 1 point, 3 rules, an endless surprise. The flap was always enough.